Let's solve this problem. If you'd like, you can click the pause button and try to solve this problem yourself before you watch the video. ABCD is a trapezoid. KL is its mid-segment. AC and BD are its diagonals. The area of a trapezoid is equal to half the sum of its bases times the altitude. Let's sub in the variables. The area of the trapezoid ABCD is equal to 2 times the product of K and H. The mid-segment of a trapezoid is equal to half the sum of its bases. KL is equal to 2K. KM is the mid-segment of the triangle ABC. KM is equal to half of BC, which is half of K. NL is the mid-segment of the triangle BCD, is also equal to half of BC, which is equal to half K. Therefore, MN is equal to K. Triangles BOC and MON are congruent because two angles and the included side of one triangle are equal to two angles and the included side of another triangle. BC is equal to MN. Angles BCO and CMN are congruent, and also angles CBO and MNO are congruent as corresponding angles. Congruent triangles have congruent corresponding altitudes. H1 is equal to H2. Since AD and BC are parallel and KL is the mid-segment of the trapezoid, by the Thales theorem, KL divides the altitude of the trapezoid into two congruent segments. Therefore, H1 is equal to 1/4 of H. The area of a triangle is equal to half the product of its base and its altitude. The area of the triangle MON is equal to half the product of MN times H1. The area of the triangle MON is equal to KH over 8. Now we can calculate the ratio of the area of the triangle MON and the area of the trapezoid ABCD, which is equal to 1/16. Therefore, the area of the trapezoid ABCD is equal to 32 square units. Thank you for watching. If you found this video helpful, please consider to subscribe to help my channel grow. Thank you.